So here's some things that you can do with a balanced chemical equation. First question is, how many moles of propane are required to produce 4.90 moles of CO2? So since we have a mole ratio here, all we need to do is say, okay, we want to have 4.90 moles of CO2, and then we make a conversion factor between CO2 and propane, and the equation says 3 moles of CO2 will be produced from 1 mole of C3H8, so you put that in there, and that's just 4.90 divided by 3, so the answer is 1.363 moles of C3H8. Next question, how many grams? This first one's pretty simple. It's moles, and that's what these coefficients are. So it can be more complicated. How many grams of CO2 are produced when you burn 454 grams of propane? So we start with the 454 grams. By the way, I'm picking that because that's the mass, the number of grams in 1 pound. So we have 454 grams of propane. We need to convert to moles first, right? So underline that. Anytime you're going to use these coefficients, you need to get to moles, and then you can use the coefficients. So we make a conversion from grams to moles, and then 1 mole of propane produces 3 moles of CO2. 1 mole of CO2 weighs 44.01 grams, and we end up with 1360 grams of CO2. Last question, right? We can also convert to molecules, to or from molecules. So the question is, how many molecules of water are produced when 29 grams of propane are burned? I put the 29 grams of propane here. I convert it to moles. Then I use the coefficients in the equation. 1 mole of propane will yield 4 moles of H2O. And then we go from moles to molecules. And our final answer, so we do 29 divided by 44.09 times 4 times Avogadro's number, and we get 1.6 times 10 to the 24th molecules of H2O. So these are some, it's conversions, but there's also a stoichiometry step. I sometimes say that. And the stoichiometry step is this one. Let's go blue. That's the stoichiometry step. Right? We've got a mole conversion from the coefficients in the equation. This is your stoichiometry step. The rest is just converting. Right? This is mole of one reactant, or mole of a reactant to a mole of product, and then this is your stoichiometry step for the last one. So the other ones are just conversions. If you're going to do stoichiometry, you need to know how many moles of reactant or product you have.